Carrying on with the raster math band tool, we just in the previous video calculated a simple SST difference by subtracting the reference SST in this file from the SST that was uh, calculated using the ocean biology group's algorithm. So this is the result. We can begin to examine this a little bit and perhaps improve upon it. So by default, it gave me a color map and a default range of temperatures. Let me try recoloring this and set the band from set the values of min and max from the band data. Well, it looks to be roughly minus 16 to set positive 17. Okay. And as a visualization, this kind of calculation where you're sort of the difference could have produced something because one was much colder than the other or one was much warmer than the other. And so you could visualize this with better with a um, sort of an anomaly color map. This is one that colors everything from the low end to the middle, one color, and from the middle to the high end, another color. And you're sort of assuming the middle is your zero temperature. Well, a little hard to see here, so let's quickly do a little dressing up of our image. I'm going to colorize the no data with black. That helps a lot. I'm also going to bring out a little bit more of the color by narrowing this range. So let me just try from, let's say, minus 10 to positive 10, something like that. We begin to see a little bit more, and you can play with those colors and bring it out however you wish. And you can examine your raster values over here while you move the cursor around and see the kinds of things. Well, maybe I can narrow it down a little more, and we'll just try minus 5 to plus 5. Okay, and that maybe is a better visualization. However, is the math band operation doesn't strictly have to operate on data rasters. It can use those masks, and those masks are very useful indeed. For example, we can look at these and apply some to perhaps eliminate SST anomaly between the reference and so on that really shouldn't be considered. If we were to try to do some statistics on portions of this, we might get in trouble because we're including, for example, cloud pixels. So let me colorize those something besides white, since white is part of our color palette. So I'll just click on this and I'll pick some unusual color, maybe a bright bluish green. Okay, so all of those pixels were by the algorithm deemed to be clouds. Okay, and so maybe it's useful to get rid of them in my band entirely and assign them a not a number value. Okay, so I'll use that as an example of a little bit more involved application of the math band operation. Let's do the difference, but let's also exclude all of our cloud ice possible pixels. Okay, so we go back to raster math band. We're going to call this declouded difference. You might come up with a more meaningful name, but that will do for now. I'm not really going to worry about all the other metadata. This is just an illustrative example. I edit my expression. So in this case, what I want to do is I want to get the difference, but only if Cloud Ice was not set as a mask pixel. Okay, now it may not be intuitive immediately, but one way to do this might be to say, well, what if I were to say, I want my SST, sorry, click just after the at, SST minus SST ref. I'm going to go ahead and select that. Could have clicked here to select all and wrap that. And then I'm going to add, I want that value, and I want the Cloud Ice mask. So let me remove my bands and scroll down here and click that. But actually what I want is, and not the Cloud Ice. Okay. So it says it's a valid expression. Hint, hint, it's not what we want. But we're going to go with it because it seems to make sense that the SST, the difference, and not one of those would give me, those pixels that are good differences. So I'm going to click OK, and I want to compute that. And this is what I get. Okay, let's come back and see that we got our declouded difference here. And let's start examining over here in the raster info. As I drag around, I'm getting ones, and in the black, I'm getting zeros. Oh, I'm getting a logical value. It's either true or it's false. And the reason for that, I deliberately did this wrong so that you can see the kind of pitfalls that you can get a valid expression. I'll use here the scrolling to retrieve this. The issue is that I'm saying I want some value and some other value, and that's a logical expression, and that's going to result in a logical value. So that's a sort of a trap to be careful of. Let's do the following. Let's trash that expression and find a better way to do this. And I'm going to use the if then else. I want to point out that this thing, odd thing right above it with the at question mark, at colon, at. That's taken from computer programming and particularly the C programming language as a shorthand of an if then else. It simply evaluates an expression question mark, and then it says give me this value if it's true, colon implies an else, that value. But we're going to spell it out here. Okay. So what I'm really saying is if what? Not Cloud Ice. There. Whoops. It put it in the wrong place, but that's okay. If not Cloud Ice, then I want to do my calculation. I'll just type it in, SST minus SST ref. Okay, I'll maybe put spaces there to be clear. Okay, we're still missing something here. Else, what do I want if it is Cloud Ice? Well, that's where I can pull one of these constants. I can use not a number. And look, okay, no errors here, so let's say okay. Let's give this new declouded difference. Click OK. And let's open that, and we get this image. So you'll notice all of these pixels that I'm dragging over that were potentially Cloud Ice and so on are now not a number. We can pick our anomaly color palette. We can set our values again, minus, I believe it was 5 we used, and positive 5. and get that image, we can set our missing data to black. Now it includes all of these cloud pixels as missing data. Okay, so that may be a better, if we're zeroing in on some area of this for statistical analysis, the statistics are not going to include pixels that the SST algorithm deemed might be cloud and ice. It doesn't guarantee it, but it's to the best of its capability. I'll take this opportunity to point out this kind of sawtooth in masks is frequently associated with another problem in the remote sensing, and that's glint. So if I click the high glint mask, what we notice is this huge area over here was deemed to be high in glint, and you could further refine this to remove those pixels from consideration of your SST difference. So let's run through that exercise very quickly. There are two ways I could approach this. I could take a MathBand. I could edit the expression. Well, I now have, turning off the masks, a new declouded difference band. Okay, so I could simply take those and then exclude any high glint pixels, or I could go back to my original difference calculation and add an expression for excluding both cloud ice and high glint. Let's do that. It's a little more complicated. It might be a little more instructive. What we again would do is we would say, well, if then else. So if, and now I'm going to create a parenthetical expression just to be explicit, and I am going to say if, and I'll do it backwards just to be even more illustrative. Let me look at my mask. If the pixel is marked as cloud ice, wish it wouldn't do that, so I'll just type it in here, cloud ice, or high glint. See the typographical problem? So let me double click that and click on high glint. Okay. So if the pixel's mask says it's cloud ice or it's high glint, then what? Well, in this case, we're going to flop the logic. Then we want not a number. And otherwise, we want our SST minus SST reference. Okay. So hopefully that's clear that the logic could go either way. I could say if not this expression, then do the subtraction else not a number, or I could do it this way. Okay. Be careful choosing or and here. I would only exclude those that were marked both cloud ice and high glint, which will only be the cloud pixels in this magenta area over here, and would not include many others. Okay, so if I click OK here, I'm just going to call this a better difference, and click OK. Go back to my file manager. All right. And in my file manager, I've got better difference. It's opened it. You can see it's now excluded the glint area. So I'll throw up my anomaly. I'll pick my values again as -5 to +5. Okay. I will colorize my missing data now. So we're kind of narrowing the amount of data from consideration, but perhaps getting more accurate statistics in whatever analysis we might be doing on this. This is a very arbitrary example, um, but illustrates the kind of power you can get from the math band operator. I think I'll close this slightly longer video tutorial here, and